Hello everyone, welcome to the session, welcome to the BYJU'S Exam Prep. How are you guys? कैसे हैं आप लोग दोस्तों? And today's we are going to discuss about the digital electronics and the topic we'll cover that is called logic gates. It's not logic families. Actually, we are going to cover the logic family of logic gate, minimization, right, of Boolean functions. And as we know, there are the two mathematical tools by which we are going to minimize the Boolean function. One is called Boolean algebra and the second one is called Karnaugh map. These two topics we are going to cover in the today's session. So Shiva, Kumar, notice started. Yes, Shiva now started. Everyone, a very good evening. And one request to you guys, please share among all of your friends so that more and more people will join the session and get benefited. One thing more, this is session is useful for the EC, electrical, right, instrumentation and for the CS student, right? So everyone, welcome to the session. Before going to start this session, let me introduce myself. My name is Chandan Jha. I have 11 plus years of teaching experience. I have completed my masters into the communication and networks. I have also qualified the ISRO exam. I have conducted more than 200 motivational sessions in various engineering colleges including NITs and some of the IITs guys. I have also qualified the GATE multiple times with the 2-digit rank. And this is my expert subject: digital circuit, control system, signal and system, communication, microprocessor and advanced communication. One thing more, in this today's session up to the K-map, everything we are going to revise in this today's session. So this is a very important session. Shiva Kamar sir, CAO, what happened? Actually Shiva, I have planned to start the COA into the app, but due to the some you can say that the features added, we are not able to plan the ones any series free series into the app. So maybe possible I will take the COA into the YouTube only, right? So don't worry Shiva, very soon we are going to cover those particular topic also, don't worry, right? Kumar, Swapnil, Kavi, Rohit, Rajnish, right? Clement, Yaldo, Shri Guru, right? Everyone, welcome to the session guys. Okay, this is my Telegram channel guys. Today's class PDF I will upload in this particular channel. So if you haven't subscribed this channel, subscribe it guys, join this channel. Okay, sir, what topic we are going to cover in the today's session? Bhargavi, a very good evening. So guys, today we are going to cover the two topics. The one is called logic gates and the second one is called minimization of Boolean function. In the logic gates, we are going to cover the inverter and OR gate, NAND gate, NOR gate, XOR gate and XNOR gate. Apart from this, there will be the inhibitor, inhibition. There are the lots of logic gates are also, but these are the basic gates which we have to study, right? Basic gate to वैसे inverter, node gate, AND gate कोई बोला जाता है. But this is called universal gate and this is called exclusive gate. These topics we are going to cover. Apart from this guys, minimization of Boolean function. So in the minimization of the Boolean function, two concepts I am going to provide you. One is called Boolean algebra and the second one is called map. Now maybe you can think is which type of, or whether we are going to discuss the question or we are going to discuss the theory portion. So everyone, let me give you the idea that today we are going to discuss about the theory as well as the question. Around 10 to 12 questions we are going to discuss in the today's session. Apart from this, briefly I will give you the idea about the theory portion also. So Alan, right, Shiva, Bhargavi, everyone, right, and make it at least 50. Are only 26 people are basically watching, so share among all of your friends. Make it at least 50, right? Okay. First, if you want to discuss very brief idea, sir, if you want to discuss about the inverter, so guys, either you can use the word inverter or you can use the word node gate. Inverter, node gate, right, negation, all having the same meaning. Negation, all having the same meaning guys. Alright Alan, thank you. Right, inhibitor, inversion, important for CC. Yes Shiva, I will discuss the few questions based on those things also, don't worry. How the node gate is basically looking like. So guys, node gate, symbol of the node gate is basically like this. Either you can write like this or you can write like this or you can write directly the bubbled. The meaning of this one is called nothing. Whatever the input you can apply, that input is going to be complement, my dear friend. Okay, now if two node gate, if you use like this, if you use this two node gate like this, then the name of this one is called, either you can use bistable multivibrator, or you can use basic memory element. In the same manner guys, if the node gate is basically looking like this, 3 node gate means odd number of node gate is basically connected in the loop. if odd number of NOT gate is basically connected in the loop, so today is the first class, yes Juhi, this is the today is the first class, right? So we can say that when odd number, I can write here also, when odd number of NOT gate connected in loop, and this one we can say that when even number of NOT gate connected in loop, even number of NOT gate connected in loop. When even number of NOT gate connected in the loop, the circuit is known as bistable, multivibrator and basic memory element. Whenever the odd number of NOT gate is connected in the loop, guys, then the name of the circuit we can say that one is called a stable multivibrator, square wave generator, clock generator. Just give me 1 minute, guys. Okay, square wave generator, after that ring oscillator, and free running circuit. We can say that free running circuit. One thing more, कि sir, signal generated by this particular method, right? Whenever the odd number of input NOT gate is basically connected in the loop, then my dear friend, the circuit having the frequency, this is called nothing, it is 1 upon 2n top PD, 2n top PD. This is the frequency generated by a signal which is generated by this particular circuit. Now, the frequency of those particular signal is called 1 upon 2n top PD, where n is called nothing, it is just a number of NOT gate, right? Shiva Kumar, sir, how memory element? Because Shiva, whatever the input you can apply here, na, if you apply the 0, here you will get 1. After that, here you will get 0. Then 0 will again come into the feedback. 0 ka 1, 1, 0. Again it will become. So whatever the input you can apply, it is going to be hold that particular input, right? Okay. And frequency, this one. One thing more, here the n is called nothing, it is just a number of NOT gate. Number of NOT gate. And that number of NOT gate in loop, right? In loop. And that should be always odd in nature. Then only we are able to apply this particular formula, right? Okay. And one thing more, guys, people who are joining late now, please like this session and share among all of your friends. यार ऐसे शेयर नहीं करोगे ना, मजा नहीं आएगा फिर. Even in the last if you'll say कि सर ये पढ़ा दो वो पढ़ा दो, if the people will not come into the live now, how we can enjoy the session, guys? So please, right, share among all of your friends, right? Okay. चलिए next. So that's what basically the NOT gate is important. If you want to discuss about the NOT gate now, this topic is important. This formula is important from where we can expect the question. Now AND gate and OR gate. If you want to discuss about the AND gate is basically looking like this. It is called A, it is called B. This one is called nothing, it is just a dot B. And one thing more, A dot B means nothing, AND gate means nothing, it is just a intersection. Whatever we have learned, frequency of multivibrator, Vikramajit, actually the frequency of generated wave by this particular circuit, right? इस signal को बनाओगे ना, whenever the odd number of NOT gate is basically connected in the loop, then definitely it is going to generate the square wave. Those square wave having the frequency f equal to 1 upon 2 n top PD, right? Okay. Now this is called NOT gate. In the detail, this is a revision session. So very quickly I'm just giving, because lots of topic are there which we have to cover into the 1 hour, right? Even we have to solve the questions also, right? Okay. This is called AND gate. Now everyone, if you want to discuss about the AND gate, this is called, right? Okay. One thing more, that every logic gates are basically designed by it is a derivative of set theory. So AND is called nothing, it is just a what? Either you can use the word AND or you can use word intersection. Intersection means what? Common. If you remember, we are using the intersection like this symbol in the set theory. Common. Okay. And how the OR gate is basically looking like. So guys, if you want to discuss about the OR gate, this is called A, this is called A ORing B. And one thing more, OR gate means nothing. It is in the set theory, whatever we have discussed about the union. This is called union. We'll discuss the question also in this particular topic. Okay. Truth table, we already aware about the truth table. If it is A and if it is a B, and if you want to discuss about the A dot B, every engineer knows about this. So I'm not going to discuss in very much of detail. 0, 0, 0, 1, 1, 0 and 1, 1. So if you want to write for the AND gate truth table, 0, 0, 0 and this is called 1. And if you want to discuss about the OR gate, guys, A, B, and if you want to write A ORing B, this is called output. 0, 0, 0, 1, 1, 0 and 1, 1. This is called 0, this is called 1, this is called 1, this is called 1. This is called AND gate and OR gate. Both follow the commutative as well as the associative law. But one thing is important here, guys, and maybe they will ask the question on those particular topic. And what is important? Ki whenever, the important topic is whenever logics are designed by TTL, designed by TTL बोले तो ट्रांजिस्टर लॉजिक, transistor. Whenever the logic are designed by the TTL, transistor logic, then floating terminal always acts as a high. Floating terminal always acts as a high. And in the same manner, guys, whenever the logic are designed by the ECL, when the logics are designed by ECL, whenever the logics are designed by ECL, then guys, floating terminal always acts as a low. Or what should be the meaning of ECL? ECL बोले तो ammeter coupled logic. ECL बोले तो what? ECL means ammeter coupled logic. ECL means ammeter coupled logic. Okay. By default, even the input is not connected. If the TTL word is basically given, the floating terminal always acts as a high. If the ECL word is given, the floating terminal always acts as a low. That 2 point you have to remember. Okay. Right, for the AND gate and OR gate. Now, next, if you want to discuss about the NAND gate, guys. In the NAND gate, how the NAND gate is basically looking like. So if you want to discuss about the NAND gate, this one is called like this. And if you want to discuss about the NOR gate, this one is called like this. NAND gate is also, right, this is called A, this is called B. So here we can write A dot B ka whole bar. And if you want to discuss about the NOR gate, this is called A ORing B ka whole bar. Now one theorem I will discuss, one that is called nothing, it is just a yes, Bikramjit, absolutely correct. One thing, guys, there will be the one theorem. The name of the theorem is De Morgan's law. Okay. Sir, previous slide, please. Okay, Bikramjit. Now. Okay. Now, by the De Morgan's law, you can break this and you can write A bar ORing B bar. In the same manner, you can write A bar dot B bar. This is by the De Morgan's law we can write. So, everyone, we can make an alternate symbol of this particular topic also. NAND gate, bubbled OR. OR gate, bubbled AND. Both having the same meaning. How we can say that both having the same meaning? So everyone, this is called A, this is called B. So definitely we can write here you are getting nothing, it is just a bar. Here you are getting B bar. And this is called OR gate, so A bar ORing B bar. And as it is, there will be no bubble into the output. So as it is value will come, A bar ORing B bar. And again, by the De Morgan's law, we can write together also. In the same manner, Presi Gold. Oh, after a long time, Presi, how are you? How's preparation going on? Okay. If you want to discuss about the AB, it is called nothing. It is just a bar. This is called B bar. So we can write a bar dot B bar, and this is called a bar dot B bar. And by the De Morgan's law, we can write this one also. Same. And this is called bubbled or, and this one is called bubbled end. Bubbled end. Always you have to remember, bubbled end itself is called NOR, bubbled or itself is called nothing. It is just a NAND. That's what we can say that. One thing more very important here. माइक के क्लिप को थोड़ा सा वो हो गया है, पर नो इश्यूज. Okay. Now guys, NAND and NOR both are called nothing. It is just a universal logic. As we know, both are called universal logic. I will share the PDF also. Don't worry, right, everyone? Full on swing. Okay. That's great. So guys, NAND and NOR both are called universal logic. So what should be the meaning of this, everyone? It means by the NAND gate and NOR gate, we are able to design all the Boolean functions. If you know that, if you have a NAND gate and NOR gate only, then any of the Boolean function you are able to design with the help of these two particular function logic gates, and that's why it is called nothing universal logic. Okay. How many NAND gate are required to implement NOT gate? 1. How many NAND gate are required to implement AND gate? 2. How many NAND gate are required to implement OR gate? 3. How many NAND gate are required to implement the XOR gate? 4. How many NAND gate are required to implement the XNOR gate? 5. How many NAND gate are required to design NAND gate? 1. How many NAND gate required to implement NOR gate? 4. That's what you can remember. Okay. Now everyone. Now if same thing, if you want to design by the NOR gate, now only for the NOT gate 1 you have to write all the values, you have to shuffle. How many NOR gate are required to design AND gate? 3. How many NOR gate are required to design OR gate? 2. Again shuffle. How many NOR gate are required to design XOR gate? Answer is 5. How many NOR gate are required to design XNOR gate? The answer is 4. How many NOR gate is required to design NAND gate? Answer is 4 and 1. One thing more. NAND and NOR are called universal logic. So how we are going to implement the any Boolean function with the help of the NAND gate and NOR gate? I have already taken the one session into the YouTube already available. If you have a doubt and if you want a more command over the particular the topic, how we are going to find out the minimum number of NAND gate and NOR gate, right, for the any Boolean functions, then you can watch that particular session also already available in the free of cost into the YouTube, guys. Watch that session, very, very important. Okay, one thing more. But I'm giving you the little bit brief idea. Whenever in the problem the minimum number of NAND gates are asked, write the function in SOP form, implement it by using AOI. AOI bole to AND OR inverter, and then you can feel it is nothing, it is just a 2-level AND OR implementation. That 2-level AND OR implementation itself is called nothing, it is just a NAND implementation. You will get the answer. Whenever in the problem they will ask about the minimum number of NOR gate, then you have to write the function in POS form, product of some form. And then if you implement it by using AOI, that is AND OR inverter, it is nothing, it is just a AND OR inverter, it is nothing, it is just a, you can say that OR AND implementation. And OR AND implementation is exactly equal to NOR implementation. Already I have discussed in very much of detail this particular topic. Okay. And just one more question I am giving you, everyone. Just give me the answer of this particular question. Which of the following can be used as a universal logic gate circuit? Which one of the logic can be used as a universal logic gate, right? And this is a MSQ question. We already know that into the gate, MSQ question means what? More than one option may be correct. Sir, for minimum, no, NOR key, I think that is remaining. NAND I have already taken. NOR also it is available, right? But separate, जैसे NAND के लिए I have taken the 2R class कि how to find out the minimum number of NAND gate only. That separate class I have not taken for the NOR gate, right? I will send that lecture also into the Telegram channel, Vikramjit. Vikramjit bhai, I will share into the Telegram channel. Don't worry. I have already given, this is called MSQ question. In the MSQ question, more than one option may be correct, right? Everyone. Only the people are basically giving the very less answer for this, right? Everyone quickly responds for this question, guys. Quickly responds for this question, right? Lots of people have given the A and C. Okay. The correct answer of this question is nothing. It is just A, everyone. A, B and C. A, B, C is the correct answer for this particular question. In Telegram channel, Vikramjit bhai, in the Telegram channel, A, B, C, both are these three options are basically correct. How we can say that? Everyone try to understand. Multiplexer, if you know that by any of the circuit, if you are able to make the expression of the NAND gate, then that circuit itself become nothing. It is just a universal logic. So everyone try to understand how the A, B, C all are basically the correct. Everyone. Suppose if you want to design NAND gate by 2 cross 1 mux. This is called mux. Now I am taking this is called A. So definitely it will become A bar and this will become A. Now if you want to design the NAND gate, now we can write this one is called 1. This is called 0. Or this is called B bar and this is called 1. So how the expression will be looking like? This is called A bar. This is called A plus B bar. And now by the De Morgan's law, if you want to write, this is called A bar plus A. Sorry, not De Morgan's law. It is a distribution theorem. A bar plus B bar. So A bar plus A equal to 1. So your answer will be A bar plus B bar. And A bar plus B bar itself is called nothing. It is just a dot B ka whole bar. Yes, it is a NAND gate. Yes, it is a NAND gate, guys. Now if you want to write, सर नेम मेंशन, यार टेलीग्राम चैनल का तो नेम पहले ही मेंशन कर चुका हूं, विक्रमजीत. इलेक्ट्रॉनिक्स बाय चंदन झा और गेट और ईएससी बाय सीजे सर. राइट, यू कैन सर्च इनटू द टेलीग्राम चैनल, यू विल गेट इट. राइट, okay. Now if you want to design the NOR gate also we can design. How? Look at the function, right? NOR gate by 2 cross 1 mux. This is called A. So definitely this will become A bar and this is called B. This is called A. Now we can write here it is a B bar and this is called 0. So what should be the value you are getting? A bar dot B bar, and A bar dot B bar itself is called nothing. It is just a or B ka whole bar. So NOR gate and NAND gate both we have designed by the 2 cross 1 mux. So mux is a universal logic. Everybody knows about that. Everybody knows about that. The mux is called nothing. It is just a universal logic. But my dear friend, now for the decoder, how we are going to design the OR gate by the help of the decoder? So everyone, by decoder, if you want to discuss, so everyone, again I am taking the 2 cross 4 decoder, 2 cross 4 decoder. So 2 input and 4 output. Now everyone try to understand how we can write. This is called A, this is called B. So this one is called A bar, B bar. This one is called A bar B. This is called A B bar. This is called A B. And I am making the enabled is called nothing. It is just a 1. Right? Okay. Now you want to write which logic you want to implement? Anything. Maybe NAND, maybe NOR. So how we are going to make the NAND gate, guys, right? Try to understand, right? So NAND gate, if you want to discuss, I just want to require a NOR gate. If you want to write A bar dot B bar itself is called nothing. You can feel this one. This is called A bar dot B bar, and A bar dot B bar itself is called A or B ka bar. So this one itself is called nothing. It is just a NOR gate we are able to implement. And now if you want to design the NAND gate, how we are going to design? Everyone try to understand. NAND gate means called nothing. It is just a dot B ka whole bar. Right? So we can write A bar ORing B bar. A bar ORing B bar. Okay. So how we are going to make it? Everyone try to understand. OR gate से चाहिए मुझे बनाना है, तो you will get the A bar. A bar के साथ if you want to discuss A bar ORing A B bar, A bar ORing A B bar, so you will get A B bar. This one is called your NOR gate. How we can say that, everyone? This is called A bar. Everyone, this is called A bar B bar plus A bar B plus A B bar. Now I'm taking the A bar common from here, so it will become B bar plus B and plus A B bar. Now this one is called A bar plus A B bar, and now by the De Morgan's law, distribution theorem, A bar plus B bar, and this is called nothing, it is just A dot B ka whole bar. NOR gate. So we have designed the NOR gate. This is called NAND gate. Every logic. Apart from this, maybe decoder is not right. Decoder is not those. So that's why the A, B, C is the correct answer. Maybe they will give you like this also, everyone. Maybe they will give you like this also. Inhibitor. This is also universal. By this also you are able to design the NAND gate, guys. How we are going to design it? A, this is called B. So here you are getting A, here you are getting B. Sorry, B को भूल जाते. Okay. Here we are getting 0 and I am connecting here A. So it is 0. This one is called A bar. Inside 0 ORing A bar. So you are getting A bar, right? Yes, sir. बिल्कुल संतोष, बहुत बढ़िया. आप कैसे हो संतोष भाई? कैसे हो? Remember, I remembered, right? मुझे याद आ रहा है. पुराने सब दोस्त दिख रहे हैं आज. वेरी गुड, राइट. ये तो रियूनियन हो गया, राइट. ओके, गुड इवनिंग कल्याण. So we can say that this is called nothing A bar, and here we are connecting the B, so this will become B bar. Now we can write A bar ORing B bar. As it is, it will come into the output A bar plus A bar ORing B bar, and we can write A dot B ka whole bar. So A dot B ka whole bar itself is called nothing, it is just a NOR gate. So my dear friend, so this one, in this system, if you want to apply like this, itself is basically behaves as a what? NOR gate, guys, right? NOR gate. Okay. Hope up to this portion everything is clear to you, everyone. So maybe if this type of expression, if they will write like A ORing B bar, this is also universal. A bar ORing B, right, B, this is also universal. A dot B bar, this is also universal. A bar dot B, this is also universal. A bar dot B bar, it is also universal. A bar ORing B bar, it is also universal. A dot B ka whole bar, this is also universal, right? All are basically the universal, guys. So you have to remember, right? Clear, बहुत बढ़िया. Merge filter channel coding. Okay, Kalyan, in the communication topic I will take, don't worry, right? Okay. Okay, one more question, everyone, given to you. One more question that is given to you. F1 is given 4, 5, 6, 7, 8. F1 is given 4, 5, 6, 7, 8. F3 is given this F3. This one is given what? 4, 5, 6, 7, 8. F3 is basically given 1, 6 and 15. And output you will get F is also given. This F is given 1, 6, 8 and 15. What should be the value of F2? What should be the value of FT? It's NAND gate. Yes. So everyone just give me the answer of this particular question. And like this session also. बहुत ही बढ़िया. Everyone, it's a very simple question, guys, right? And one thing more, tomorrow on Sunday at 10 p.m. I mean 11:15 p.m. Tomorrow at 11:15 p.m. guys, tomorrow at 11:15 p.m. I'm just going to come again, and where we are going to discuss about if you are facing any problem while the preparation of the gate. And the last moment, we already know that people, maybe they have accelerated their preparation in the month of January and February. They have done the fantastic things. They have revised the subject in good manner. But maybe possible in the month of the December and the January, the most of the guys are basically getting frustrated. So guys, the pure motivational session I'm going to take tomorrow at 11:15 p.m. on the same channel, guys, right? So must attend the session, highly recommended. Already the entity was created, guys, so you can see that entity also, right? Okay. Everyone just give me the answer of this particular question. Option C, C, C. Lots of people are basically giving the absolutely the correct answer of this question is nothing, it is just a C. How we can say that, everyone? Try to understand. Sir, 1, 6 is given here, already we know that. Here already we know that 1, 6, 15 is there. So 1 is there, 6 is there and 15 is there. Now this is the OR gate. F1 is given 8. So what should be the value of 8? Sir, here if 8 will come, simple 8 will come, that also the correct answer. It means the F2. If 8 will come, then also it should be the correct answer, because here you are getting 8, here you are getting 168, so you will get the correct answer of this particular question. But in the 8, none of the option is basically matched. Okay, no issues. Now instead of 8, if they will select, so 8 is also the correct answer. Apart from 8, if 6 and 8 is basically given, if here the 6 is also given, then you will get the common is 6 and 8, because AND gate means common. So here you will get nothing, it is just a 6 and 8. So common again 1, 6, 8, 15. 1, 6, again you will get the same answer. So 6, 8 is also correct answer. But if you will take the 4 now, here, then 4 must be contained into the F. But if you follow the option, my dear friend, or answer, there will be the no 4 will be basically given into the output. So option in which the 4 is there, that is the wrong, that is the wrong, that is the wrong. So correct answer of this question is nothing, it is just a C. So Hemalatha, Kumar Kokila, Kalyan, right, Bhargavi, Anu, these are the 5 or 6 people has given the correct answer. Rest one is only the object. बाकी की तो सिर्फ प्रवचन सुनने के लिए है कि प्रिय भक्त जनों, बाबा जी का ज्ञान बट रहा है, लपेट लो. You have to respond, guys. Okay. One more question, everyone. One more question is basically given. And this is a GATE previous year question. This is a GATE previous year question. The logic gate shown in the digital circuit, X0, X1, X2, X3. Again, X0, X1, X2, X3. They are the 4 variable is there. And how many combination are possible? How many minterm you can write with the help of the 4 variable? So with the help of the 4 variable, we are able to write total 16 expression, right? But they are not asking like this. What they are asking? Ki sir, the logic gate shown in the digital circuit below, use the strong pull down NMOS transistor. Strong pull down CMOS NMOS transistor for low logic level at the output. When the pull down are off, high value registers set output logic levels to high. It means it is nothing, it is just a AND gate is given. So actually by this expression, if you observe, they have given nothing, it is just a AND gate, nothing more than that, right? Right, one thing more. Note that some nodes are intentionally shorted to implement the wired logic. Such shorted nodes will be high only if the output of all the gates whose output are shorted as high. The meaning is this nothing, it is just in which of the logic. If all the input is high, then only the output is going to be high. That is called AND logic. So this shorted terminal is called nothing, it is just a AND logic. This is called AND. Here this is also called AND. So this shorted terminal itself basically behaves as a nothing, it is just a AND logic. That's what they have given in the question. Now, the number of distinct value of x3, x2, x1, x0, right, of the 16 possible value that given the output equal to 1 is. Everyone just give me the answer of this question. How many combination are there for the x3, x2, x1 in which you will get the output that is called y as a high? How many combinations are there? Everyone just give me the answer यार. और ऐसे में मजा नहीं आएगा. जब भी कभी अच्छे लेवल के क्वेश्चन आते हैं, the few people are getting very frustrated and they are leaving the session. Even it is a very good, this type of question, this is already the GATE previous year question, right? Okay. Everyone just give me the answer of this question, guys. Okay. Now everyone try to understand how we are going to write it. Sir, this is called x0, so here you are getting x0 bar. This is called x0. Okay. This is called x1 XOR x2. And this is called x3 bar. So this one is called nothing, it is just a x3. This one is called nothing, it is just a x3. Now, everyone. This is the output here. What should be the output you are getting? Suppose I am writing this is called Z, or this is called P. Suppose I am writing this one is called P. So what should be the value of P? And this is called suppose Q. So this is called Q. So this P is called nothing. This P is called nothing. I am writing here. Output of this P, right? Okay, this P is called nothing. It is just a X naught into, right, X1 XOR X2. This one is called like this. Okay. Yes, now Kalyan has given only the correct answer. Now in the same manner, guys, this is called X3 given. So if you want to write, oh, no. You will get at this terminal is the value is called nothing. It is just a Q, right? Okay. So Q is given. Q is basically given X1 XOR X2 into X3 bar. This one you will get X1 XOR X2 into X3 bar. And if you want to write this output, suppose I am writing this output is called nothing. It is just a, this one is called Q. Okay. And if you want to write the P is called nothing. It is just a X naught into Q, X naught dot Q. That is called P. बहुत ही बढ़िया. And now this terminal, whatever the value you are getting, suppose this is called, मैं एक value ले लेता हूँ R. So R is called nothing. It is just a X naught bar into P. Right. And Y, if you want to write, this is called R plus X3. So you have to solve this value R only. If you'll get the value of R, directly you are able to solve this question. अरे नहीं हो रहा है क्या इतनी, तो बेटा आगे छोड़ दूं, सेशन को छोड़ने की क्या जरूरत है, आगे बढ़ जाते हैं, छोड़ देते हैं. मतलब एक तो सपने भी देखेंगे कि आग लगा दूंगा सर दुनिया में, कोई माचिस और लाइटर दे दे, और जब अच्छे लेवल का क्वेश्चन आता है तो मतलब हालत भी खराब हो जाती. राइट. तो देखो बेटा कैसे, हाउ वी आर गोइंग टू सॉल्व इट. देखो, फर्स्ट इफ यू वांट टू राइट द वैल्यू ऑफ Q इज एसेंशियली रिक्वायर्ड, राइट. ओके. So if you want to solve the Q, what should be the value of Q? Sorry, Q is called X1 bar, X2, X3 bar plus X1 bar, X1, X2 bar, X3 bar. This one we can say that, right? XOR. Okay, sir. So Q we know that. Now how we are going to write the P? P means X naught we have to multiply with this expression. So I am writing the P only here. P is called nothing. X naught is multiplied with the Q. So Q naught we have to multiply with this expression. So we can write X3 bar, X2, X1 bar, X naught plus this one if you want to write X3 bar, X2 bar, X1, X naught. This one is called nothing, it is just a P. And now my dear friend, P already we know that. Okay. Now R if you want to find out, we have to again multiply it with the X naught bar. This P is multiplied with the X naught bar. So if you multiply it with the X naught bar, this term is going to be 0. This term is going to be 0. Because everywhere there will be the X naught, right? Or already we know that everyone. Ki here X naught bar, here the X naught. So these two things is multiplied. So R is always going to be 0. Right? No, Shiva. So R is always going to be 0. So Y is called nothing. It is just a X3 only. X3 bar only. Sorry, X3. Not X3 bar. X3. Y equal to X3. Right only. Now how many combinations are possible? So total by the 4 variables, 16 combinations are possible. And in which combination the X3 is going to be 1. Only 8 combinations are there in which the X3 is going to be 1. And those are basically the answer. So only the 8 combinations are possible, guys. देखो ना इसको आप ऐसे समझ लीजिए. Oh, sorry. You can write like this. Total 16 combination are possible. In that combination only the 8 combination are there where the output should be what? 1. X3 should be 1. देखो the 16 combination 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 1 1 0 and 0 1 1 1. One zero 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 1 0 0 1 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1. This is the combination. And now you can feel this is called x3, x2, x1, x naught. How many combination are there? If I'll write the output should be only depend on the x3. Output is called x3. So only in this case you will get the output is 1. Rest 1 is the output is 0 only. So how many combination? That's what basically asked into the question. Okay, how many combination at which the output is going to be high? So 8 combination are there on which the output is going to be high, and that's why, my dear friend, the correct answer of this question is nothing. It is just a right 8. 8 is the correct answer. Very good. Yes, Kumar Kokila. So hope you understood. If you understood, then one more question I'm giving you, everyone. Just give me the answer of this question. Again, it's a very simple question, guys. Not that much of tough. It's a very, very, very simple question. Sir, how to place AND gate exactly? Because that is basically given, na? Shiva, already that is mentioned in the problem. Ki wired shorted circuit will be behaves, output will be high only when all the input is high. And the meaning itself is called nothing, it is just an AND logic. In the AND is a logic in which whenever you will apply all the input is high, then only the output will be high. That is called AND logic. That's what already mentioned in the problem. Okay, one more question, everyone. Just give me the answer of this question. People who having the basic idea about the NAND gate, they are going to solve this question very easily within the 30 seconds or 1 minute. People who does not have any idea, right, maybe it will take a more time to solve the questions, right, everyone. So quickly solve this question, guys. Quickly solve this question, everyone. Everyone, respond for this. Okay. Okay, how we are going to solve this question? Everyone try to understand. This is called P, everyone. So this one is called nothing, it is just a P bar. This is called Q, so here you are getting Q bar, right? Okay. Okay. This one, if you want to write, this is called nothing, it is just a P bar dot Q bar ka whole bar. So this one is called nothing, it is just a P or in Q. In the same manner, it is R and S. So this one you are getting nothing, it is just a R plus S. Again, everyone, the meaning of this one is called nothing. This is called OR gate. You can replace this circuit. It means these two node gate, you can replace it as a OR gate. You can replace it as a OR gate. Right? So these two things is also you can replace as a OR gate. So this is a OR gate. Or we already know that bubbled NAND itself is called OR. Bubbled NAND itself is called OR. Bubbled NAND itself is called OR. So your answer is called P ORing Q, R ORing S. Now we can say that if you want to write it, so P plus Q ka whole bar, R plus S ka whole bar, and Y is called nothing, it is just a P plus Q ka whole bar dot R plus S ka whole bar ka whole bar. So this is called P plus Q plus R plus S. B is the absolutely correct answer of this question. Again, right? So Bhargavi, Kalyan, Shiva, Nikhil, Kavi, Shri Guru, everybody has given the correct answer. Very good, guys. Very good. Acha. Now let me give you the brief idea about the XOR gate also. So how the XOR gate is looking like? So everyone, this is called XOR gate, and this one is called nothing. It is just a XNOR gate. XOR gate, if you want to write, this is called A, this is called B. So we can write this one is called A XOR B, and this one, if you want to write, this is called A XNOR B. Here we can write this is called A bar B plus AB bar in SOP form. Here if you want to write, this is called A bar B bar plus AB, right, into SOP form. In the same manner, we can write into the POS also, right? How we can write POS? If you want to write, we can write A ORing B, A bar ORing B bar. This is also a XOR expression. Oh my God, दोस्तों, among us we have a Sanjay Rathi sir also. So sir, स्वागत है आपका इस सेशन में. Everyone, please welcome to the Sanjay Rathi sir also in our session. और आशीर्वाद ले लो बेटा. हाँ. Okay, everyone. Here if you want to write, how we are going to find out? सूरज, भार्गवी, बहुत बढ़िया. अरे कम से कम बेटा, कभी बोलते कोई आते हैं अपने सेशन के अंदर आप लोगों को आशीर्वाद देने के लिए, तो आपकी रिस्पॉन्सिबिलिटी बनती है थोड़ी सी कुछ ले लो, राइट? आशीर्वाद ले लिया करो. क्या पता कब कहां पर किस तरीके से काम आ जाए. ये है सर हमारे आज की पीढ़ी. ये है हमारी आज की पीढ़ी, जिनको किसी को विश करने में भी एक अजीब सा लग रहा है. मतलब 4 लोगों ने अभी तक विश किया है और फिर कहते हैं सर हमें सक्सेस क्यों नहीं मिलती है. बेटा, सक्सेस के लिए दुआओं का होना भी बहुत जरूरी है. खाली ये XOR गेट और XNOR गेट मिलके कोई सफल नहीं बना जिंदगी में. पीछे बैकबोन भी आपकी अच्छी होनी चाहिए, दुआएं अच्छी, अच्छे कर्म होने चाहिए. हाँ, आधे लोग तो ढीठ है, उनको कुछ फर्क नहीं पड़ता है. This one is also called XOR gate, right? XNOR gate. This one is called XNOR gate. शिवा, विश तुमने किया ही नहीं, सीधा मतलब आदेश दे रहे हो कि हेलो सर, टेक 1 प्रैक्टिस सेशन. पहले थोड़ा विश करो. हाँ, कंफर्ट जोन में लाओ सर को. बहुत ही बढ़िया. चलिए, XOR gate. Now how the truth table of the XOR gate is looking like, guys? So if you want to write the XOR gate truth table, it's very simple. Or XNOR gate truth table, it's again very simple. ओके, 0 XOR 0 आपको मिलेगा 0. दिस इज कॉल्ड 1, दिस इज कॉल्ड 1, दिस इज कॉल्ड 0. Here if you want to write, this is called 1, this is called 0, this is called 0, this is called 1. So this is the truth table of XOR gate, this is the truth table of XNOR gate, right? One thing more you can remember, guys, for the XOR gate and XNOR gate, if you write A XOR A, so value will be 0. And if you write A XOR A bar, the value will be 1. In the same manner, if you want to write A XNOR A, the value will be 1. And if you write A XNOR A bar, the value will be 0. And one thing more, if you want to write, if one come inside, another should go outside. A XOR 0 equal to A. A XOR 1 equal to A bar. A XNOR 1, if one come inside, another should go outside. A XNOR 0, it will become A bar. This is called looking like this. बहुत ही बढ़िया. So XOR XNOR. Okay, one question I'm giving you, everyone. Just give me the answer of this question. Answer of this question. यहां मैंने दे दिया x and this is called 1, and now I'm asking about the y, and this is called 1, this is called 2, this is called 3, and this is called 1999. Everyone just give me the answer of this question. Everyone just give me the answer of this question. Quickly respond for this question, guys. Quickly. Okay, how we are going to solve it? Sir, मन तो और कर रहा है पढ़ाऊं, but as a student, very much or very we can say that the large amount of the student are basically serious for the GATE preparation. That is indicated in front of me by the numbers. कि that much of the student are very much serious about the GATE preparation. So मैं बहुत ही मतलब मुझे खुशी की बात फील हो रही है कि लगभग 20-22 स्टूडेंट है जो बहुत ज़्यादा सीरियस है. उसमें भी फ्लक्चुएशंस होता रहता है. कुछ लोग तो सिर्फ चेक करने के लिए आते हैं, मजे मजे में वीडियो देख रहे होते हैं डिजिटल का, बगल में अगर मान लीजिए वो आलिया भट्ट का डांस चल रहा होता है तो सब कुछ छोड़ के वहां चले जाते हैं और फिर कहते हैं जिंदगी सेट नहीं हो रहा है सर. बहुत डिमोटिवेशन होता है सर पढ़ने. x XOR 1 x बार XOR 1 बार का बार, और बार का बार इज कॉल्ड नथिंग अगेन द x. Again x XOR 1, sir, x bar. So you will feel the odd number of output is x bar and even number output is called nothing, it is just a x. 1999 is called nothing, it is just a odd number of logic gates. So this is called nothing, it is just a x bar. So the correct answer of this question is nothing, it is just a x bar, right? So Bhargavi, Shiva, Kavi and Kalyan, these are the people, 4 or 5 people they have covered, given the correct. बाकी के तो सब ऐसे आए हुए हैं, बस पढ़ाओ सर, मैं देखता हूं कौन रोकता आपको पढ़ाने से, जी खोल के पढ़ाओ बस, राइट? चलिए, one more question. I am giving you this question as a homework, guys. Just take this question as a homework. Right? Just take this question as a homework. Now, let me give you the brief idea about the Boolean algebra also. That is given by the George Boole. The one theorem that is called distribution theorem. What should be the distribution theorem, sir? A plus B, or we can write A plus BC. So we can distribute the A with B and A with C also. That is called A plus B and A plus C. That is called distribution theorem. Maybe it is given into the terms of POS also. Suppose A dot B plus C is given. So we can distribute the A with B and we can distribute the AC with C also. That is called A dot B plus A dot C. In the SOP also, in the POS also, in the both manner we can write. Okay, that is called distribution theorem. Second one is called consensus. Spelling galat hogi, but no issues. Consensus theorem. How we can write, sir? This is called AB plus A bar C plus BC. 3 terms of 2 variables. Each variable repeated 2 times. Only one variable repeated in the form of the complement. The answer will be that one only. So isko how we are going to minimize it? It is called AB. It is called A bar C. Here the A is missing, so I am writing A bar plus A, and this is called BC. Now everyone, this is called AB, this is called A bar C, this is called A bar BC plus ABC. And now I will take the, everyone, here we can take the AB common, 1 plus C, and here we will take the A bar C common, so 1 plus B. So answer is called nothing, it is just a AB plus A bar C. This one is the answer. So always everyone try to understand. If the function is given AB plus A bar C plus BC, the answer will be AB plus A bar C. 3 terms. Each term containing 2 variables. Each variable repeated 2 times. Only one variable repeated in the form of complement. The answer will be that one only. Right? Okay. Suppose if the question is given A, B bar plus A, C plus B or plus BC. Suppose this one is given. So again the answer will be what? This one. B, this one. Only B and B bar is there. Again 3 terms. Each term containing 2 variables. Each variable repeated 2 times. Only one variable repeated in the form of the complement. The answer will be that one only. So we can write the answer is A, B bar plus BC will be the answer. It may be happened into the everyone. Yes, I will remove the AC. Yes, correct Kalyan. Okay, one thing more everyone. One thing more guys. अजीत तिवारी साहब यार थोड़ा symbol change कर लो यार. It's very horrible. Right? गुस्से वाला symbol है. Make it at least smile. Right? जिंदगी में यार लोगों के पास बहुत गम है अजीत मेरे दोस्त. बहुत गम है. Right? तो कोशिश करिए कि उस गम को कम किया जाए, खुश किया जाए. आप भी खुश रहें और लोगों को भी खुश करें. राइट? और इंटरव्यू में बहुत काम आएगा दोस्तों. The interview is all about how you are making the end, or you can say that the feel, or how much or you are feeling the comfortable, and you are making the other people also the comfortable during the interview. Totally depends upon that. So interview भी आपके एक आपका जो attitude होता है उसके ऊपर पूरा depend करता है, right? So one thing more in the POS also maybe it will be happen like A plus B, A bar plus C, B plus C. So answer will be again A plus B, A bar plus C. In the POS form also it may be open. वो ऑनलाइन क्लास के लिए सही. अरे कोई दिक्कत नहीं दोस्त, कोई दिक्कत नहीं. अच्छा जी, आफ्टर दैट ट्रांसपोज थ्योरम, हाउ वी आर गोइंग टू राइट द ट्रांसपोज? इट इज कॉल्ड A plus B and this is called A bar plus C. Whenever the A plus B and A bar dot plus C, it means whatever the value is given in the first position, that should be written in the complement into the first position also. यहां और यहां दोनों आपस में complement होने चाहिए. The next may be complement, may be same, may be different. It does not make any difference. But first find first complement. Then we can write the first with the last and last with the first. That's what we can say that transpose. So AC plus A bar B. Right? AC plus first with the last and last with the first. Only it will be happen when first and first should be complement of each other. Right? Okay जी. Transpose. And next one is called guys De Morgan's. A dot B dot C का whole bar. सबका बार तो छोटा छोटा बार. A bar और ing B bar और ing C bar. And A और ing B और ing C का whole bar. Then we can say that A bar dot B bar dot C bar. सबका बार तो छोटा छोटा बार. Break the line, change the sign. Break the line, change the sign. Right? This one is the answer. Okay, बहुत ही बढ़िया. Now we are moving into the next everyone. अब बात करते हैं K-map की भी. पर K-map की बात करेंगे और K-map पर बेस्ड कुछ क्वेश्चंस करेंगे everyone. I'm just giving you one question as a homework. This is called C, this is called 1, this is called bar, है ना? C bar. This is the question I'm giving you as a homework guys. You have to write the answer of this particular question into the, tomorrow also we'll discuss the some questions, right? But everyone, you have to take this question as a homework and you have to write the answer into the comment box. Just after the completing of this particular video, you have to comment in the comment box. You have to write the answer, right? Everyone. So guys, thank you very much. All the very best. Hope you enjoyed this session, and if you enjoyed this session, just share among all of your friends. एक question और homework के लिए दे ही देता हूँ for the K-map. This is also question of homework. Take the snapshot. And you have to write the answer of this particular question into the comment box, right? 2 questions I have given as a homework. This is the first and this is the second. This is the second. कल्याण ने आंसर दिया C. हाँ, कल्याण बहुत बढ़िया. रोहित ने दिया A. मन तो कर रहा है सॉल्व ही कर दूं. Okay, just take this question as a homework, no issues. And this question also as a homework, guys. So hope you enjoyed this session. And guys, see you tomorrow, right around 8. Tomorrow is, I think there will be no class on the tomorrow. Day after, tomorrow at 11:15, yes. Tomorrow at 11:15, guys. 11:15 बजे रात को. Motivational session. Alright, motivational session at 11:15 a.m. Motivational for what? GATE 2022. Must attend the session. Yes, right. Yaldo, I will share into the Telegram channel. Just after the completion of class, I will share into the Telegram channel. So guys, thank you very much. All the very best. Right. Thank you. And if you haven't downloaded the BYJU'S Exam Prep, download it guys. Right. Thank you everyone.